Okay, welcome back, everybody. Please click on Follow Presenter, and I'll grab the link for the next lesson. So the question earlier was, do we have different join types, left, right, and inner? And we do, actually. Um, Different transformers use different verbiage for this, but there is a transformer which specifically uses this wording. So I'm just going to go through some of these transformers. Ultimately, there are four transformers that we can use for these non-spatial, these attribute-based merges. And then there's two additional transformers, which technically, yes, they can do them too, but in a slightly different way. So I'm just going to go through the list of some of those transformers. And I'll make sure I remember to share my screen here. So in the upcoming exercise, we're going to be working with two data sets. We have parks and we have parks. Separate data sets, different formats. Ultimately, what we want for an output is all the features that we have here with these attributes, but it's missing two attributes. We don't have a park address and we don't have a park URL. So we're going to be joining them based on park name. Now, when we look at these two data sets, we have a map info tab file, it's a spatial data set, and we have a file geodatabase, also a spatial data set. So there are some other ways that this join could be done. If I was going to do it spatially, I'd probably do it with a spatial filter transformer. So that will do it spatially. But imagine instead that there's no geometry for this data set here. If there's no geometry for that other data set, could be a CSV file, could be another database table, then we're going to have to use some of the joining transformers. Just want to quickly see if we still have them in the categories here. So in the categories, there is a transformer category in the transformer gallery called filters and joins. You can see that we have 35 transformers here. These are all the different ways that we can join features together. The first transformer you should think of whenever you have to join based on attributes is the feature joiner. This is a newer transformer than the others I'm going to mention. It has better underlying technology, it is faster, and it uses wording which is a bit more familiar to people who are familiar with SQL or SQL. We have a couple of different joining modes that we can do, inner, left, and full, and we can connect that up and do the join. The feature joiner replaced another transformer called the feature merger. This was the original merging transformer. The feature merger is slightly slower. It doesn't use the same wording as the feature joiner, but the wording that it does have is a little bit easier to understand, and it has a couple of different outputs available to you. This one has joined, unjoined left, unjoined right. This has merged, unmerged requester, use supplier, and unused supplier. So this will let you know what's been used as well. So in this one, you're just getting the joined. This will basically be telling you what is joined from the right side. So you can do a bit more quality assurance stuff on this. Now, realistically, you can get that effect by just adding a tester transformer after the feature joiner. So the feature merger, slightly older, slightly slower, uses non-standard wording, but ultimately the same behavior. There is one other thing the feature merger can do that the feature joiner cannot. When you're doing your requesters here, you can open up the text editor. So you can basically create composite keys within the transformer itself. The feature joiner does not allow you to create composite keys within the transformer itself. That's not a huge deal. You could just put an attribute manager or an attribute creator before the feature joiner. So it really comes down to personal preference. If you are better versed in SQL, go with the feature joiner. If performance is important, go with the feature joiner. If you don't care, try them both, see which one you like. The next joining transformer is, we've renamed it recently. I always called it the joiner. It is, in fact, the database joiner. One of the things that you'll notice in the quick add here is that some of the transformer names have a little arrow coming out of them. They're aliases. Every now and then we rename a transformer. The database joiner is an example of that. If I select joiner here, it actually drops in a database joiner. The database joiner is a little bit different. It is similar in concept to the feature joiner, but the database joiner actually has a reader built right into it. If you're using the database joiner, it's because your parks, you don't actually have that in your data set. It would look like this. We connect up parks, and then in the database joiner, oh, I better connect it up here. In the database joiner, we would indicate what data set has the additional features. And it will then, as each feature comes in, make a request of that database, get the matching features, bring them back, and attach them. So why would we want to do this? This comes down to having a little thought experiment about the nature of your data. If the number of features that require these additional attributes is pretty close to the total number of features in this database, you might as well read them both in and join them up. Performance will be faster. But if this is a very large database, this is a very large database, and this only has a couple of features, reading in this entire database is a bit of a waste of time. We might as well make the request of the database, grab just the features that we want, and then attach the attributes and continue on. So if these two data sets are similar in size, feature joiner and feature merger, if this data set is enormous, like let's say there's 300 million features in this, and I only need 10 parks, reading in those 300 million features, what's the point in that? I could just make the request of the database. Now, keep in mind that as you make the request of the database, that takes time as well. So a feature comes in, makes the request, gets the feature back, passes it out. So there is an overhead to that communication time. Eventually, I'll have enough features where it just makes sense to read in the entire other database. Another thing to keep in mind is that the feature joiner and the feature merger, they have to compare features to other features. These are blocking transformers. If I have very large data sets, that's going to start filling up memory and eventually caching to disk, and then the performance suffers. So if, there's a bit of a trade-off here. This one is blocking, database joiner, not blocking. Feature comes in, makes a request, passes the feature out. Very low memory overhead. So there's sort of an interaction of bottlenecks here. As to which one's the best one to use, ultimately, you just have to benchmark it. You can do the sort of experiment in your head. I'm only reading 10 features. I have a huge database. Better to use the database joiner. I have a lot of features and they match up pretty well to what's in the other database. Read them both in, use the feature joiner and feature merger. Okay, so that's a lot of information about those three transformers. I've got three more I want to talk about here. If you are really good at SQL, you can use the inline querier. This allows you to read in a number of data sets and then basically create a database on the fly and do SQL queries against it. I've never been that good at SQL, so I have never actually used the inline querier. But if you are really good at it, give it a shot. Now, this does require that you read in all those data sets. So that's kind of like the feature merger and feature joiner. There is kind of the equivalent to the database joiner for the inline querier. Those are the SQL executor, which will run a SQL query based on an initiator. And you can also just start with the SQL query using a SQL creator. The SQL creator allows you to read in a database, read in a number of tables, and do a SQL statement against them. Now, this does require that everything be in the same database. But if it does, then you can just start with the SQL creator or the SQL executor. Do the joins in the database, and then continue from there. Now, generally speaking, if you have a large amount of data in a database, the more of the more processing you can push to the database, the better. Databases are optimized to do that sort of thing. They're very fast at doing that sort of thing. And then you can do whatever else you need in FME. Okay, so that's pretty much all of the joining transformers. So let's do the next lesson. So please do choose a join transformer, and we'll continue at 9:34. Good luck, everyone.